Hi, everyone. This is Miss Rapp. We are doing Unit 6, Lesson 10, Polynomial Inequalities, pages 95 to 100. Let's get started. Graph the polynomial function below using any solving method necessary. Then answer the questions below in interval notation. Okay, so we've had some pretty intense few lessons about putting everything together and really using all of our tools in our toolbox to be able to graph and investigate polynomials. Today will be no different. We're going to look at inequalities, but we're going to use some of our old tricks to get us started. Okay, so step one, to graph, I need x-intercepts. So I need to find my x-intercepts, and I'm going to find these by factoring, by grouping first. If I can't factor, I have to use rational root theorem. If I can't factor, you have to use rational root theorem. Let's try to factor first. And the reason I know I can at least try to start by factoring is because I have 1, 2, 3, 4 terms and 4 boxes. So far, so good. 1, and then -4. That works. So I get x squared minus 4 times x plus 1. So then I know that one of my x-intercepts is x equals -1, multiplicity 1. And then I also know if I solve this, so that's plus or minus 2, multiplicity 1 for each of them. And that makes sense, guys. So remember that your multiplicity adds up to your degree. So I have 1 multiplicity and then 2 right here because this is plus or minus. So that gets to degree 3. So that's really good. Okay. End behavior. Well, this is, my function is, my degree is odd. My LC is positive. Odd positive is down, up. That's from lesson 1. So if you're still confused on this, please sign up for office hours. Intercepts and multiplicity, well, we just found that here. We know it's going to be at -2, 0, multiplicity 1, 2, 0, multiplicity 1, and -1, 0, multiplicity 1. I like to mark them here. It's just easier. My y-intercept is going to be 0, -4, and I got that because of that -4. Okay, we are ready to graph. So I'm going to throw all my intercepts on. I'm going to put my end behavior in. And they're all multiplicity 1, so I'm just going to pass through everything. Pass through, pass through, pass through. Some of you might be like, well, isn't that a bounce? Y-intercepts don't get multiplicities. Okay, let's think about this. Where is the graph equal to 0? Oh, well, that's all of these. So that's going to be x equals -2, -1, 2, because they're all on y equals 0. Where is it bigger than 0? So we're going to answer it in interval notation. So bigger than 0 would be above this line. So I'm actually going to get a highlighter. You guys all know how much I love to highlight. So greater than 0 is going to be above the y-axis. So, well, it's greater than 0 from -2 to -1, union 2 to positive infinity, right? We're doing our interval notation. And then where is it less than 0? Well, I see 2 segments where it's smaller. So that's going to be -infinity to -2, union -1 to 2. Okay, we answered the question. Let's do the next one. Highlighting is going to totally help. And they're just more fun that way. Okay, let's start the next one. I'm going to do the same thing. Okay, so this is a quadratic. I'm going to see if I can factor it. I'm trying to multiply to -10 and add to -3. 5 and 2. And the 5 is going to be negative. So because my a value is 1, I can do the trick. H of x equals x minus 5, x plus 2. So I know my intercepts are x equals 5, multiplicity 1, x equals negative 2, multiplicity 1. My end behavior. So I just found my intercepts. That's good. And I could just find my y-intercept is going to be 0, negative 10 because of that negative 10. So my degree is even, and my leading coefficient is positive. So that's up, up. Remember, this is lesson 1. That was a long time ago. Intercepts and multiplicity. I have 5, 0, multiplicity 1, negative 2, 0, multiplicity 1. So I'm just rewriting this here. My y-intercept is 0, negative 10. Okay, let's graph. So I've thrown my intercepts first. And remember, this does not have to be perfect. It just has to have like the right shape. So I'm going to be up, up. So, and I'm going to pass through all of them. Pass through. Pass through. That's it. That's it. Where is the graph equal to 0? X equals negative 2, comma 5. Where is the graph greater than 0? Well, this section is greater than 0, and this section is greater than 0. So greater than's in blue. And then less than I'll do in yellow. So I would say from negative infinity to negative 2, whoops, I'm above 0. Union 5 to positive infinity, because I'm above. Less than 0, I would say between negative 2 and 5. I'm using my x values to make all this. This right here, like the highlighting and the greater than or equal to and whatnot, that is going to help us with our lesson. Okay, let's get started. Let's move on. Okay, let's write down our steps. Steps for solving polynomial inequalities. Step 1, factor. Or use RRT to find intercepts. And then solve for x-intercepts. Step 3, graph. Step 4, use the graph to find sections that satisfy the inequality. I'm going to say intervals instead. Intervals. Okay, write those down. Let's get started. Let me adjust this. Solve the polynomial inequalities and write your final answer in interval notation. So I want to know when this function is greater than 0. So I'm going to start by factoring. So I can factor out an x. So let's try the area model. And if that doesn't work, we have to use rational root theorem. So that can be x cubed. That can be a 2. I could put the biggest number I can pull out of here is a 2. And then the biggest number I can pull out of here is a negative 1. This doesn't work. So it doesn't factor. Sad. So we're going to use the rational root theorem. So you guys get to see this in action. This is P and this is Q. So remember, we're doing P over Q. So the factors of P are going to be plus or minus 8, 1, 4, 2. The factors of Q are going to be plus or minus 1. So P over Q is going to be plus or minus 8, 1, 4, 2. So I'm going to grab my calculator and see if 1 or negative 1 works. I need to find a 0. So this is really where lesson 9 comes into play. So we learned this the last time. So I'm going to try, I always try negative 1 and 1 first. So I'm going to show you guys my table trick again. X cubed minus x squared minus 10x minus 8. Some of you might be like, well, I don't have a calculator like that. You could just do it by hand. It's not a big deal. Second table, let's try negative 1. Oh, cool, guys. When I plugged in negative 1, I got 0. So that means negative 1 goes in the box. So then I put all of these. 1, negative 1, negative 10, negative 8. Also, I already have 2 of my x-intercepts. I already know that one of my x-intercepts is 0 because of that x. Multiplicity 1, x equals negative 1, multiplicity 1. And now so I have 2 out of my answers. I need to find the other 2. So I'm going to synthetically divide. Yay, no remainder. That's a good sign. It means you're doing all your work right. So we get, oh, well, the factors are x from that x minus 1, and then we get, so this came from x3, x2, x0. So I get x squared minus 2x minus 8. I can factor this even more using the area model. Well, what multiplies to negative 8 and adds to negative 2? Multiplies to negative 8 and adds to negative 2. That's going to be negative 4 and positive 2. So to add to my list, now I can find that x equals 4 multiplicity 1, x equals negative 2 multiplicity 1. Your multiplicities add to your degree. 1, 2, 3, 4, degree 4, we're good to go. So I'm going to graph this now. And then we're going to figure out where it's above 0. So just like we did on the front, I'm going to plot my intercepts. So 0, 0, negative 1, negative 2, and 4. So I have 1, 2, 3, 4, so we're good. My degree is even, and my leading coefficient is positive, so that's going to be up, up. And all of them are multiplicity 1, so I throw in my, so these are all going to be pass-throughs because they're multiplicity 1. So I go pass through, pass through, pass through, pass through. Okay. So it says I want to be greater than or equal to 0. Greater than or equal to 0. That line under there is going to change from our interval notation. Well, I know I'm above 0 here, here, and here. So let's write that. So normally you'd have to test every section, but if your graph is correct, you're good. So I would say from, oh wait, I can fill it out right here. From negative infinity to negative 2 bracket, because it said or equal to, I'm above 0. And then union, so that's this section right there. union -1 to 0, and these have brackets for the same reason, union 4 to positive infinity. That is our answer. That is our answer. But we did a lot of work to get there. It is really hard to just do this thoroughly in one try. You have to go slow, you have to make mistakes, you have to try different strategies. Everything you learned in the beginning of this unit were tools. Now that these tools are in your toolbox, you can answer these big problems. Okay, one more, let's do it. Okay, same deal. I want to know when this is less than 0. Less than, and less than means parentheses. So let's start by trying to factor. Well, I can factor out an x. Okay, let's try the area model. I'm trying to multiply to -18 and add to -7. Please work so we don't have the rational root theorem. 9 and 2, nice, nice. -9. So because my a value is 1, I can rewrite this like this. If you guys are like, how does she just keep doing that? When your a value is 1, whatever goes on these lines goes in your parentheses. That's the trick. So I know that my intercepts are x equals 0, multiplicity 1, x equals 9, multiplicity 1, x equals -2, multiplicity 1. Oh, I just realized I forgot to do the number line on the last problem, so I'll show you guys here. It's a pretty simple tool. Okay. Because 0 is an intercept, that also means the y-intercept, so let's just start plotting. So there's 0, 0. Let's call that -2. We'll call that 9. So when you have this, that's also your y-intercept. So my degree is odd. My leading coefficient is positive. Odd positive is down, up. So I'm going to throw that in there. And let's find our graph. So I'm going to pass through all these because they were all degree 1. Multiplicity 1, sorry. Okay, it says, when is it less than? Well, this is below 0, and this is below 0. So in interval notation, I would say, so here's how you use this. 0 with an open circle, -2 with an open circle, 9 with an open circle because of the less than, there's no equal to. So in interval notation, I know from -infinity to -2, parentheses because of the less than, union 0 to 9. So what that looks like on here, I would just go like this. I would like shade here and shade here. So that's what it looks like. Okay, once again, you guys, I understand this stuff is tricky, but please ask questions, okay? Your teachers want to help. Do the video check and have a great day. Bye.